Okay, hi and welcome to Video Notes 10.7 Quadratic Formula. This is the Big Daddy, the one that does it all. This method of solving quadratics works on every form of the quadratic. We've seen some that work if there's no a value, right here, or I'm sorry, no b value. So we've seen that value and we've been able to solve that by square roots. We've also seen all the factoring ones, so you can factor and solve it. But this one, without any to do, without anything to do before, as long as it's in standard form, it works. That's the great part about this one. Now, the downside, because everything can't be awesome all the time, otherwise we just teach you one method and call it a day. The problem with this one is it does tend to be the most on the calculation side. So where it always does work, and if you want to make it your favorite, you absolutely can. The calculations aren't difficult, but there are more. So this one is your default always backup kind of thing if you'd like it to be that way. Plus, there's a little piece of this b divided by, or b squared minus 4ac, which is the discriminant, and we've already visited that. So a portion of the calculation you should have already done a few times. So this quadratic formula, we're going to explore it today. You do need to memorize it at some point. I probably will give it on my quiz so that you don't have to. But with that being said, what I'd like to do is I'm going to blow this right up about there, and you'll notice the note over here. This note says copy for your notes or go to the OneNote on there, because I'm not going to do these ones here. I'm going to let you look at those. I'm pausing the video you're pausing the video as I'm talking, and you're going to write those down or go to the OneNote. Because on the back side, when I flip over there, we're going to do 3 examples that'll cover everything that you need to see for this quadratic formula and all the little parts that come out of it. All right, so go ahead and pause the video, write those down, and I'll see you on the other side. Okay, here we are on the back side, and I'm going to do 3 examples from here. And the 3 examples I'm going to do, one of which is going to be a rational example, which to you means it's going to be integers or fractions. Pretty nice numbers to work with. Those are the easy ones. Everything kind of goes nicely. Then we're going to do an example with the irrationals, which means that we'll have a square root left over somewhere in the solution, which we can simplify or we'll leave. Okay, and then the final one is going to be complex, where we have forms of I. Okay, so the first example we're going to do is a rational solution, meaning that it should come out pretty nice for us. I went ahead and copied the quadratic formula, or QF for short, for us at the top. You want to write that at the top each time you use it. Don't start plugging numbers into it. Mistakes will fly from that if you do. So let's go ahead and start plugging pieces in. There is a song. You can look it up and memorize it that way if you'd like to, but let's just go ahead and write it down and start plugging parts in. First thing I'd like to do is identify your A, your B, and your C. Have them clearly identified, because you can usually see a mistake if you forgot to do something. Namely, that you have to make sure it's in standard form. And standard form says that your quadratic term is first, your linear term is next, and then your constant. We do have that, and it is set equal to 0, which means that it is a solve. That's what that means, correct? So let's identify our A, B, and C. Our A happens to be -3, our B is 5, and our C is -2. You do want to take the signs with the coefficient. All right, now that we have those, let's start plugging it in. It looks daunting when we start plugging it in. But what you want to be aware of is that if you do it in little parts, each of these are pretty easy calculations. So we're going to write x equals, because that's what we're going to get out of there, x-intercepts. We're going to put opposite R5 or opposite B. I use parentheses anytime I plug a number in, and that makes sure that my signs are correct. Plus or minus, we've seen that with our square root solving. Let's make a nice long radical for us. Then it's b squared. Again, if this was a negative b, those parentheses would be key, because you would get a wrong answer if you didn't. Minus 4 times a, which is -3, times -2, which is our c value. Just to point out, this is our discriminant. So if this comes out to be positive, there are 2 solutions. If it comes out to be 0, there's 1 solution. And if it comes out to be negative, we're going to find no solutions or imaginary, or solutions with an I. Okay, so that's how you're going to tell where we're going to end up with this. All right, so that part's done. Let's go ahead and do all of that divided by 2 times our A value, which is a -3. All right, so now that we've got that there, we're really kind of done with the first step. All we have to do now is calculate. So far, so easy. So let's do little pieces at a time. Let's clean those parentheses out of there. We don't need them anymore. Plus or minus isn't changing yet. Let's clean up underneath this radical though. So 5 squared is 25. And then count your signs here. We got 1, 2, 3 signs, which means that my ultimate answer there for those 3 multiplications is going to be negative because I've got an odd number of them. So 4 times 3 is 12. 12 times 2 is 24. So I'm going to end up with a negative 24 over there. I'm going to draw a line, not do any more calculations with that, and I'm going to go ahead and multiply 2 times negative 3, which is going to give me negative 6. Again, it's starting to look a little better, but we still have some work to do. So negative 5 is still hanging out, plus or minus our square root of 1 all over negative 6. And my next step, let's jump over here, I'm going to go ahead and clean out that square root of 1 because square root of 1 is 1. 1 times 1 is 1, so it's a perfect square. So I'm going to write negative 5 plus or minus 1 all over negative 6. And it's tempting to say, Mr. Hallam, I don't know what to do with this. But we've seen this plus or minus. We know that it's going to make a numerator of negative 5 plus 1, and it's going to make a numerator of negative 5 minus 1. So really we need 2 solutions from this, right? 2 intercepts we're going to get. So let's clean this up. Negative 5 plus 1 is going to give me negative 4 over negative 6. The other way is going to give me negative 5 minus 1, which is going to give me negative 6 over negative 6. So let's clean both of those up. Negative 4 divided by negative 6, the two negatives are going to become positive, and then 2 and 6 are going to reduce to a 2/3. Right? So, and then we can go ahead and turn that into a point as 2/3 and 0. This one here, negative 6 over negative 6, is going to be 1, and that's also going to be a 0. Okay, so what I mean by rational is that this value here and this value here are integers or a decimal. So this is a rational answer. Those are the ones that you usually like because they come out to be nice, and you can usually make them into points. But let's take a look at the next one. This one's going to result in an irrational solution. So I'll rewrite the formula for us here. So x equals opposite b plus or minus the square root of b squared minus 4ac all over 2a. So again, let's identify our a, our b, and our c. So to do that, we need to make sure that the quadratic term is first, then our linear term, then our constant term. And that looks to be the case. So let's go ahead and identify a as 2, b as 4, and c as negative 7. We should end up with a square root when we're all done with this. Okay, just keeping in mind, you wouldn't know that until we got there, but since I've said it, that's how we know. So let's plug in all our parts. So x equals opposite 4 plus or minus our square root of b squared, which is 4 squared, minus 4 times a times c. I'm going to extend my root there. All over twice my a value, which is 2. Okay, so we've got the setup there. That looks pretty good. Let's go ahead and start cleaning things up. Okay, so let's start cleaning this up then. So we've got x equals negative 4 plus or minus. Let's do our two pieces underneath our square root. 4 squared is 16 minus, well, let's check our signs. We got 2 signs, so that's going to be a plus. 4 times 2 times 7 is going to end up being 56. Okay, all over 2 times 2, which is 4. Again, nothing difficult so far. All right, let's clean these up here. So we get negative 4 plus or minus our square root of 72 all over 4. Now we're pretty close to being cleaned up, but there are 2 answers mixed in here, and we really should represent it as 2 answers. So let's continue this process, and additionally, we also have to simplify this radical down here. So let's go ahead and do that. 72 so happens to be 36 times 2. So you might be able to pull a calculator out and do that if you don't know that. We're going to break that up into square root of 36 times square root of 2. And the reason that we want to use 36 there is because 36 is a perfect squared term. So we're going to have negative 4 plus or minus, and this is going to go ahead and reduce out to 6 square roots of 2 over 4. Now we're really close at this point. We've got a radical reduced, we've got these, but you can see that there's a value of 2 divisible between these 2 answers that we've got here. So let's break this up and simplify this down. So we're going to split it up into negative 4 plus 6 times the square root of 2. So negative 4 plus or minus 6. Oops, not plus or minus, just plus. Plus 6 square roots of 2 over 4. And we're going to break it up into negative 4 minus 6 square roots of 2 over 4. And if we clean this up, this 2 is going to be divisible in both of those terms. Or better yet, it would look like this. Negative 4 divided by 4 plus 6 square roots of 2 divided by 4. I know there's a lot of intricate work. I'm trying to show all my steps so you can kind of see what's going on. This is going to reduce to negative 1 plus, and then there's a 2 divisible here. So I'm going to reduce those down, 3 square roots of 2 over 2. That's what that one's finally going to look like. And we're going to leave it like that because it's a irrational answer because there's a square root in there. So we wouldn't want to take it any farther, otherwise we're going to get into an estimate of decimals. So let's clean this one up as well. We're going to split it up into its two numerator parts. So we're going to get negative 4 over 4 again. This time we're going to have subtract, and we're going to have that 6 square roots of 2 over 4. Or that's going to turn into negative 1 minus 3 square roots of 2 over 4. So that's going to be our two solutions. We actually want to be able to separate those so that we can see both x-intercepts if we wanted to. All right, we got one more to go, and this is going to be a complex solution. So in this one, we should see an I, which means that we're going to have a negative square root, or a negative for our discriminant. Again, let's rewrite our quadratic formula. X equals opposite b plus or minus the square root of b squared minus 4 times a times c all over 2a. Let's identify our a, our b, and our c. It is in standard form, so a is 2, b is 6, and c is 7. So let's start plugging in our parts. So x equals opposite b, or negative 6, plus or minus the square root of b squared, which is 6 squared, there's our b, minus 4 times our a value, which is 2, times c, which is 7, all over 2 times our a value, which is also 2. Okay, so let's start the cleanup. So we're going to have negative 6 plus or minus the square root of 36, 6 squared, right? Minus 4 times 2 times 7, so it's going to be negative, and 4 times 2 times 7 is 56, all over 4, which is 2 times 2. Let's go a little bit more. We get negative 6 plus or minus 36 minus 56. You can see the negative coming out now. Square root of negative 20, all over 4. Now we're pretty close. You can see we're getting towards the end, but we do need to get rid of that negative underneath the radical and make it I, and we need to clean up 20, which will reduce. So we're going to have negative 6 plus or minus. I'm going to break this radical up into negative 1 times the square root of 4 times the square root of 5. And 4 is a perfect square, so that's going to square root out all over 4, of course, first. Let's go down a little bit more. Equals negative 6 plus or minus. This is going to change into I now. That's going to turn into a 2. They are multiplied times the square root of 5. We'll rearrange those in the next step. I do like to show all of my steps. All right, so negative 6 again, plus or minus 2 times I times the square root of 5 is 2i square roots of 5 all over 2. Oops, all over 4. Now, before we split these up into 2, let's just go ahead and look at how that worked before. We were able to reduce both of these. So let's go ahead and do that reduction here now. So 6 and 4 are reducible, so that's going to turn into negative 3 plus or minus, and so basically we're dividing a 2 out of each of these terms. So this 2 is going to go away. It's going to turn to an I, square root of 5, and then we're also going to divide a 2 out of the 4, which is going to go to 2. So it's easier sometimes to do the reduction before we separate them. So our separate answers are negative 3 plus I square roots of 5 over 2, and we're going to have negative 3 minus I square root of 5 over 2. Again, if you looked at all of this in one big step, way crazy. If you look at each individual piece as we go, stuff that you're very confident and able to do, not so bad. But as I told you at the beginning, quadratic formula is a lot more work. However, it does always work, and it is always the same. So there are three types of answers: rational, integers, and ratios. And then we're going to get a irrational, which has got a square root in it, and we're going to get imaginary or complex. Actually, we should probably call this complex, which has an I in it. Okay, that's the three. You just learned how to use the quadratic formula and how to plug all the stuff in. All right, we'll see you in class.